Welcome to Lesson 8. At this point, you should know all there is to know about using user accounts. Now we need to find out how to secure them. In this lesson, you'll learn all that is necessary to pass the permissions-related questions on RHCSA exams. We will first talk about working with basic permissions. That sub-lesson is followed by an explanation of special permissions. The final part of this lesson explains how to use access control lists, which is useful for advanced configuration of Linux permissions. At the end of this lesson, you'll work through the first scenario-based end-of-lesson lab exercise. You should notice that this is an important type of exercise, as it helps you work on more complex tasks, where you first have to interpret the question before you can get started on tasks that are required to pass this exercise. So let's have a look at ownership and how ownership relates to users, groups and others. I'm going to show you an example, and that is the home directory. If we do an ls-l, we can see the files that exist in this directory, and we can see information about permissions as well. So in here, for example, there's a home directory of user Caroline. This home directory has an owner, which is user Caroline. And it has a group owner, which is group Caroline. Now you can see that for every file and every directory there are permissions. And the permissions are what I've highlighted here. So the permissions are specified in groups of 3. So it starts with RWX, which relates to the user. Then we have nothing, nothing and nothing, which relates to the group. And then we have another time 3 times nothing, which relates to others. Now this user, groups and others is something that is very important to understand if you want to understand Linux permission. The thing is that on Linux, every file, every directory has an owner. The owner is the user, and the user has specific permissions. And every file has a group owner. That's the group from user, group and other, and the group has specific permissions as well. And apart from the users and groups, there is others. And others is just everyone else, which has not specifically been mentioned here. Now, if Linux needs to determine what the permissions are that a specific user has to a file, Linux will first look if the user is the owner. Now, if the user is the owner, the permissions are applied. If the user is not the owner, Linux will check if the user is maybe a member of the group that is group owner of the file. And if that's the case, the permissions will apply. And if it's not the case, then the user will automatically get the permissions of others. What is also important to understand is that the algorithm is exit on match, which means that if you are the owner, you get the permissions of owner and Linux doesn't look any further. And if you're not the owner, only in that case, Linux looks to see if you are a member of the group. And if you are a member of the group, the permissions will be applied and Linux doesn't look any further. So this is all you need to know before you start working with permissions.
To manage permissions on Linux, you first need to manage ownership. That is because in order to determine which permissions a user has, the system checks if the user in question is the owner of the file or the directory. Next, it checks if the user is a member of the group that is owner, and if that's not the case, the system checks which are the permissions that are assigned to the others entity, and the user will automatically get the permissions that are assigned to others. So let's have a look at some default permissions in the home directory, which contains user home directories. So what you can see in here is, for example, the home directory of user Julia. Now what we can see here is that there is a user, Julia, who is the owner of the home directory of this directory, Julia, and there's a group Julia, which is the group owner of the directory, Julia. As you know, on Red Hat, private group assignments are used, so when a user is created, automatically a group with the same name as the user is created, and the user is the only member of the group. So let's have a look at an example that I prepared in the data directory. There are two subdirectories in here, which is account and sales. I created them as root, so the directories are owned by the user root and the group root. Let's make sure we understand what's happening here. So the user root has these three permissions, which is read, write and execute. The group root has these two permissions, which is read and execute, and others, which is not mentioned here because it's just everyone else, has the last set of three permissions, which is read and execute as well. Now imagine that this is an environment where you want people to be able to work in a shared group environment. So everyone who is a member of the sales group must have permissions to write in the sales directory, and everyone who is a member of the account group must have permissions to write in the account directory. Because Linux works with user, group and owner, the best approach is to make sure that the group sales is the group owner of the directory sales, and the group account is the group owner of the directory account. In order to grant these owners, we use chgrp for change group. So change group sales sales and change group account account. Let's have a look again. And you can see that the group owner has now been set. Now it depends if you want to change the user owner as well. Currently root is user owner. That is because the user root has created the directory. Now in some cases it may be useful to make the head of the department user owner of a shared group directory. So if Laurie would be the head of the accounting department, it makes sense to use CHOWN for change owner, Laurie on account. And if Lisa would be the head of the sales department, well, CHOWN Lisa on sales. And you can see now that the owners have properly been set. Now this is the first thing that you need to take care of before even starting to think about the exact permissions that you want to grant on directories. And how that works you will learn in the next sub-lesson.
So in this lesson I'm going to explain about basic permissions. Now the idea of basic permissions is that there have been three different sets of permissions, and that is because Linux permissions were invented back in the early 1970s, and the needs for computing in those days wasn't the same as the needs are currently. And that is why a couple of years after the basic permissions some other permissions have been added, and still later access control lists have been added as well. And I'll explain those later in this lesson. So the basic permissions, there is three of them. There is read and write and execute. And these permissions can be used on files as well as directories. Even if it may seem obvious what the permissions are used for, I want to take some time to explain them anyway. So you can use these permissions on files as well as on directories. Let's start by talking about read on files. So basically the idea of read on files is that a user is capable of opening a file and do whatever the user wants to do with it without making modifications. So let's write down open. Now an interesting one is read on directories, because some people think that read on directories means that the user can read all the files in a directory, and that is wrong. Read on a directory means that the user can list files that are in the directory. So the user can see which files are in the directory, but the user cannot read the files, because you need read rights in order to open the files and read the contents of these files. Then we have the write permission. Write on a file means that a user can modify the contents of the file. And write on a directory means that the user can modify the contents of the directory. But what exactly does it mean if you can modify the contents of a directory? Well, basically it means that users can add or delete files to the directory. And then we have execute. Execute is a very specific permission on Linux, and it's the permission that makes Linux a secure operating system. Because execute on a file means users can run the contents of the file, if the contents of the file is executable program code. And the interesting thing is that no file on Linux has execute permissions by default. And that makes Linux relatively secure. Imagine, for example, a Linux user who is receiving an email attachment. Well, the email attachment cannot run by default because there won't be any execute permission on it. Then we also have execute on the directory, which is a bit special. It means that users can do cd. So a user can use the cd command to go in the directory and do whatever he wants to do with this directory. So this is all you need to know about the use of the basic permissions on Linux. So in this sublesson I'm going to show you how you can manage basic permissions. Before starting the demonstration, I want to explain a couple of things. In this demo you will learn how to use the chmod command to change permissions on files and directories. Let's have a look at a couple of examples. The first example is chmod 750 on my file. You can see that 3 different digits I used in the command to change the permissions for my file. To understand these digits, you should know that read equals 4, write equals 2, and execute equals 1. And you should also know that the digits refer to UGO, which is user, group, and others. So if we see 7, 7 is 4 plus 2 plus 1, that means user gets read, write, and execute. If you see 5, 5 is 4 plus 1, that means that group gets read and execute, and 0, that means that others gets nothing at all. You can do it in an alternative way as well, by using chmod u plus r, g minus w, o plus x on my file. That is a relative mode, but I wouldn't recommend using that because it's confusing, and if you use the absolute mode that is using the digits, it's much more clear what exactly you want to accomplish.
So we have just set appropriate ownership. Now let's have a look at the permissions themselves. You have learned that read, write and execute are the default standard permissions on Linux. So if you have a look at the current permission settings for the group's account and the group correct is. Now if you have a look at the current permission settings for the group directories, account and sales, you will see that the owner has read, write and execute, the group has read and execute, and others has read and execute as well. Now that's not good, because we want members of the group to be able to create files in their group directories, and also we probably don't want just anyone to have permissions to access these group directories. In order to change that, you can use the chmod command. In the chmod command, as I've just explained, you can use absolute mode and relative mode. Absolute mode is by far the easiest if you want to work with simple permission assignments like this. So I can do chmod 770 on account, which makes the permission settings for user read, write and execute. Group will get read, write and execute, and others will get nothing at all. Let's do an ls-l and you can see that it is all set. Chmod can also be used in a relative mode, so if I do chmod g plus w on sales, you can see that the group sales now has read, write and execute set. And if I do chmod o minus rx on sales, I take away read and execute from the sales group. And you can see that now everything is set correctly. So to set permissions you will use chmod, and in order to do chmod it is important to understand that read equals 4, write equals 2 and execute equals 1. That is absolute mode, and in relative mode you just add or take away the permissions to the specific owner to set the permissions.
So before applying the special permissions, let's have a look at the special permissions and what they mean. I've put them in a slide so that you can easily refer back to the slide to understand what we're talking about. So the first special permission is set user ID. It means that if it's applied to a file, that the user can run executable files as the owner of the file and not with his own user permissions. On directories it doesn't have any meaning. Set group ID means that if you run executable files, it will run as the group owner and not with the permissions of the user owner. You should notice, by the way, that set user ID and set group ID are both dangerous permissions if applied to file, and you will possibly never ever use them in your life as a Linux administrator. Now, set group ID on a directory means that group ownership is inherited on all items that are created in the directory. And that is a very useful permission for setting up shared group environments. Then we have sticky bit, which doesn't have a meaning on files, but on directories it means that you can delete files only if you are the owner or if you are the owner of the parent's directory. And that is also a very useful permission for setting up shared group environments, because with this permission one member of the group cannot delete files that were created by another member of the group, which I will also show you in the demo in the next lesson. So before showing you how to manage special permissions, I just want to give you a quick overview of the special permissions that are available. So first there is set user ID, which has the value of 4 if you want to use chmod in the absolute mode, and you can also use u plus s to apply it, using chmod of course. We have set group ID with a digital value of 2 and g plus s if you are using chmod in the relative mode. And we have sticky bit with a value of 1, and you can use plus t, or optionally if you want to, O plus t if you want to set up using chmod in the relative mode.
So let's have a look at the special permissions. Some people have a problem understanding set user ID. As I just explained, set user ID means that the script or executable is run with the permissions of the owner of the script. So let me do an example, and let's go to the home directory of user Lisa. And let me create a nice little shell script in here. Let's call it game. So as every shell script, it should start with a shebang that indicates that it's a shell script. And then we friendly say, hi, do you want to play a game? We have the shell script wait and completely ignore the answer and execute a friendly command like this. Okay, I hope I don't have to explain that this is a very dangerous shell script indeed. Now, in order to make this an executable script, which by default it isn't, I need chmod plus x on game. And do an ls-l, and we can see that the script is now executable. You can imagine that it's a bad idea if I run it as root, but let's do it as user Lisa. So su minus Lisa to become Lisa, and I do an ls, and Lisa thinks, hey, this is nice, this is this nice little game, let's run it. Okay. What is important to understand is what will happen if Lisa is actually going to start this game. Well, basically she will start the game as Lisa. So if the script is going to try to remove many files, it will do it as Lisa and as no one else. So the worst thing that can happen is that Lisa, her home directory, is wiped and everything else where she has permissions to write to will be gone as well. And that is bad, but not that bad, because only things that Lisa has write permissions to are affected. Now let's do set user ID. So in order to understand set user ID, we need to have a look at the properties of the file. You can see it is owned by user root and it is owned by group root. Set user ID means that if the file is executed, it will execute as the owner of the file. So to set user ID, I would do chmod u plus s on game. Let's do an ls-l, and you can see that it is marked in red, which indicates that something potentially dangerous is going on here. And now let's become Lisa again, and Lisa sees this file again. Oh, how nice! Let's play a little game, and can you imagine what happens? Okay, that is why you don't want to use set user ID anytime. In my 22 years with Linux, I have never had an occasion where set user ID was the only solution for a problem. Don't use it ever. Set user ID is only applied to some system files. Let me show you that. To find those files, I'm using find /-perm, which will find files based on their permissions, /4000, which means that the first digit in the permission settings must be a 4, which, as you've just seen, is set user ID, and the other ones we don't really care. We see a couple of error messages. And then we see a list of files that do have set user ID for very good reasons. Now one of those files is user bin passwd. That's the binary that allows users to change their password. Let's analyze why. Let me do ls-l user bin passwd first. You can see the S on the position where you normally see an X for execute for user indicates that it is set user ID. Now, why does passwd have set user ID? Well, that is because the password has to be written to the etc shadow file. And as you can see, there's no permissions whatsoever on the etc shadow file, which means that only a root can access the etc shadow file, which is good. But if a user wants to change his password, it needs to be written anyway to the etc shadow file. And that is why the user takes a root permission at the moment that user bin passwd is running. And there's nothing wrong with that, because passwd is a well-written program and it has securely been analyzed, and there's nothing wrong with it. So basically there are some system binaries that contain set user ID, and keep it like that and never ever try to use the set user ID permission on anything else. Now, as we have learned, there are two other special permissions that are important. I have explained set group ID, which is basically the same as set user ID, so you're not going to use that. What you are going to use is the set group ID on a directory. So let me show you how it works. I'm becoming Lisa. Before doing that, I'll use ID on Lisa, and we can see that Lisa is a member of sales. Now I don't want Lisa because she's a member of sales and she's also the owner of the directory. You know what? Lisa is also a member of account. And given the fact that the group account is group owner of the directory account, and the group account has read, write and execute on directory account, Lisa should be able to write files to the directory account. Let's try that. So I'm going to the directory account, and as Lisa I'm creating a file using touch lisa1. Let me do an ls-l, and what do we see? Well, the file has been created with the user that created the file as the user owner and the primary group of that user as the group owner. Now what's wrong with it? Well, what is wrong with it is that the other members of the group account don't have any write permissions to the file, and that's not really useful in a shared group environment, and that is why we have set group ID. So let me do chmod g plus s on the account directory. And let me do ls minus l. You can see the little s on the position where normally there's the execute for group. And let's become Lisa again and go to the data account directory. Touch Lisa 2 and ls minus l, and as you can see, the file is now automatically group owned by the group account. This is something very important for your exam, because on the exam you might very well have a question that asks you to set up a shared group environment where all the members of the group will automatically get write permissions to any files created in a shared group environment. And if they ask you that, you have to do it by using set group ID permission. Now let me talk about the sticky bit. Sticky bit, as we've just seen, is a permission that prevents users from deleting files which they don't own. So if sticky bit is set on a directory, a user can only delete the file if the user is owner of the directory or if the user is owner of the file. So let me check if we have anyone else who is in a group account. So grep account on etc group would help me find that out. So we have Lori. Lori is a member of account as well. So let's do su Lori. And as Lori, I go to data account and I create some files. You can see that the group ownership is set correctly. Now what would be interesting is Lori allowed to execute rm-f on the file Lisa1. Of course she is, because she is a member of the group account, and the group account has write permissions to the directory, and write permissions to the directory means that you can delete anything in that directory. Now the big question is if Lisa is going to be happy with that. Probably not, and that is why you need sticky bit. I'm just doing chmod plus t on star, because sticky bit is something that you also want on any shared group environment. You can see an uppercase T on the position where there's normally an X for others. It's an uppercase because there's no X behind it. It's just sticky bit. It would be a lowercase if there's X behind it. Same goes, by the way, for the set group ID that we see here on the directory as well. It's a lowercase s because there's an X behind it, and it would be an uppercase S if there wouldn't be an X behind it. So let me become Lori again. She goes to data account. She sees some files and she will do an rm-f on Lisa2, which is gonna be allowed? Now why is that? Must be an obvious reason. Let's check. Hey, do you see that? Lori was the owner of the directory, and as the owner of the directory, she's allowed to remove any file from the directory. So doing this as Lori was a bad example. We want to do it as Lisa. So let's become Lisa. Let's go to data account. And let's do an rm-f on Lori1, which is not permitted because of sticky bit. And that is why sticky bit is something you want on any shared group environment. By the way, we do have it by default on the system as well. If you do an ls-l, you can see the little t on the tmp directory. Because tmp is a directory where anyone can write files to, and you typically only want the owner of the file to be able to remove a file if necessary.
The last addition to the Linux permission scheme was access control lists. And before applying them, you should understand why you would want to use them. The idea of access control lists is that it makes it possible to give permissions to more than one user or group on a file or a directory. Normally a file has just one user who is owner and one group that is owner. With access control lists, you can grant many permissions to one group and a little bit less to another group. Also, access control lists can be used to set the default permissions for newly created files and directories for a specific directory environment, which is pretty cool because using access control lists, you can make sure that whatever file is created in a specific directory always gets the right permissions, which is very useful in shared group environments. If you want to use access control list, you must make sure to set the ACL mount option. This mount option is not supported in all file systems by default, so in many occasions it's a manual action. And you can do that using the mount options in the etc fstab file or in systemd. I will explain later how you will do that in systemd. In etc fstab you should already know how to do that. Then you can use tune2fs for exe file systems to put the mount option not in a separate file but to make it a property of the file system itself. Which is a good idea because it means that if the file system is ever moved to some other server, the properties will automatically be moved with it. In XFS you don't have to do anything because it is a default mount option. So before I'm starting the demo, it's also good to have an overview of what exactly we are going to do. There are two commands involved in managing access control lists. First, there is the setfacl for set file access control list. And that is what you use to set. And there's getfacl, which is what you use to get an overview of current access control list settings on files. So one example of setfacl is setfacl-m g:sales:rx on /data/account. The important part here is the g::sales::rx, which tells us that the group sales is getting read and execute. Alternatively, you could do something like u::lisa::rx to specify read and execute for the user Lisa. Something else that you need to be aware of is that after setting an ACL, you also need to set a default ACL that takes care of all items that you are going to create later in the same directory. It is extremely important that you remember that in order to set ACLs properly, you need to use two commands. First, there is setfacl-m g: and so on, which takes care of already existing files. Then there is setfacl-m d: and so on, and d: means that it is setting a default ACL. And this is going to take care of all the files that you are going to create later in the same directory. You want the permissions for these files to be set properly as well. So ACLs, always you will need two different commands to set them.
Enough talk about access control list. Now let's see how it works for real. In my data directory, which we've previously talked about, you can see there's an account group and there's a sales group. Now imagine that the sales group needs access to the account directory and the account group needs access to the sales directory, but you don't want to grant any permissions to others because that would just give away too many permissions. In such a scenario, access control lists offers an ideal solution. Because you can just grant one user or one group as the owner of a directory, and what we need here is a second group that is granted on a directory. You cannot just do chgrp because that would remove the primary group assignment. So what we need to do is set facl to create the access control list. There are two commands in order to manage access control lists. That is get facl, which shows the current access control lists. I didn't set any access control lists yet, but I want to show you what it looks like. Basically, it shows the same information that ls-l is showing. So the file name is account, the owner, which is the user, is Laurie, the group is account. We have some flags, which is the set group ID and the sticky bit, and here we can see the permissions of the user and the permissions of the group. But wait, there's one thing that is very important to realize when working with access control lists, and that is that access control lists is copying over the current permission settings to the access control list settings, which means that before starting to do anything on access control lists, you want to make sure that your permissions are all set the way you want them to be. If after setting access control lists you are going to change the permission settings, you'll end up in a mess. The system was just not created that flexible that it can deal with that. So make sure first to take care of all permissions, and once you've done that, start using the access control lists. So we want the sales group to have read permissions on the account directory. To do that, we need set facl -m for modify. I'm doing -r as well for recursive, which is going to set the access control lists on any items that are already existing in the account directory. Next, I'm specifying a g:"sales" followed by the permissions I want to grant, and then I specify the name of the directory. And then it gives me an invalid argument near character 1. Now why is that? That is because order does matter in the set facl command. So what is wrong with this command is that -m needs to be followed by the string of what exactly you want to modify. So g:"sales:"rx is an argument for the -m option. And -r needs to be in front of that. You see, now it doesn't complain. So let me do a get facl on the account directory again. And you can see that there's a second entity that has been added. So the group sales with read and execute permissions. There's also a mask. Please just ignore the mask. It's not important and it's dealt with automatically. If you want to understand the mask, it is really hard to understand, and it really isn't anything you want to modify yourself. So just ignore it. It doesn't really matter. Okay, what we've done now is we've taken care of all items currently existing in the accounts directory. But what we also need to do, we need to take care of new items that will be created in the accounts directory. And to do that, we need a default ACL. Now, setting a default ACL is not too hard if you have this previous command done already. Take away the -r because you don't do default ACLs recursively, and add the colon. You see, that's just a 4-letter difference. The rest of it, you can leave it as it is. Now, this will take care that the current permission and ACL setting on the account directory will be inherited to any items that will be created in this directory. So let's have a look first. Get facl on account again. You can see some extra information has been added. So the default settings, there's default user RWX. So what has happened is that it takes the permissions of the user and it will grant those permissions as default permissions to any new files. So the user will be owner with these permissions on any files created beneath. Then we have the group, which is account, and that by default will get read, write and execute. And we have the group sales, which by default will get read and execute, and we will have others, which by default will get nothing. So let's go to account and let's create a directory, 2014 for example. And if I do get facl on 2014, you can see that we see exactly the same settings as on the parent directory, which is exactly what we wanted. Now, if we are going to create a file in this directory, and we do a get facl on that file as well, you can see That is different. Now why is that? That is because on a file you don't need default settings, because you are not going to create anything beneath a file. A file is a leaf object by itself, so you can't create anything in it. What you also see is that the mask has become active. And that is because on Linux you never want to grant the execute permission automatically. The mask is taking care of that for you. So the default ACL tells us that the group would get read, write and execute, but because of the mask the effective permissions are read, write. And it would tell us that sales would get read and execute, but because of the mask sales would get just read. And others still has nothing. And this is basically how ACLs are working. What you need to remember about ACLs is that when setting ACLs on directories at any time you need to use two commands. The first command, let me do a history. The first command is this command, command number 1041, which takes care of existing items and the directory itself. The second command is command 1043, which takes care of any new items that will be created below this directory point. Now I do realize that this isn't very easy to do and you may have a hard time remembering the exact command, but fortunately there's a very nice man page for the setfacl command. If you go all the way down you can see that there are some examples, and there's just one example that matters, and that is this one. Once you found this example, I hope also during the exam you will recognize the basic structure of the setfacl command, and you'll be able to set access control lists to whatever files that need it.
So exercise 8 is an important exercise. It gives you an overview of a scenario-based exercise. The idea of the scenario-based exercise is that you start thinking and interpreting what you need to do before really attacking. So we need to set up an environment for shared data groups, and it must meet the following requirements. You have to create 4 users: Caroline, Lisa, Laurie and Bob. It doesn't matter if one of the users is already existing, you can just reuse it. It doesn't really matter. Next you need to create 2 groups, which are sales and account. You need to make Lisa and Caroline member of the group sales, and Laurie and Bob need to be a member of the group account. And next you need to create a directory /data/sales where members of the group sales can read and write files, and members of account can only read files. And then you need to create the directory data account where members of the group account can read and write files, and members of sales can only read files. So what I would recommend before starting this exercise is just to do the exercise in your head. Don't start typing immediately, but start thinking before you start typing. That is also a skill that is very important during the exam, because before starting typing it's good to know where you're heading to and what you want to do. So think before you actually do it, especially for this exercise, which is a relatively complicated exercise. Good luck with it.
So did you enjoy exercise 8? You probably didn't, and that is normal. It is normal because it's a complicated exercise, but it's a very important exercise. The way the questions are asked looks a little bit like the way the questions are asked on the exam. So before starting to type you should read the entire exercise and try to understand what exactly you need to do. So in step 1 we see that you need to create some users. That's easy. Then you need to create some groups. That's easy. You need to make the users member of the groups in step 3 and 4. That's easy as well. Next, in step 5, that is where it really becomes important. You need to create the directory data sales where members of the group sales can read and write files, and members of account can only read files. So that means we need to do chgrp to make the group the owner of the directory. It means we need to do chmod to apply permissions, and it means we need to do setfacl to create some access control lists. And the same goes for step 6. So we don't need any of the special permissions, which is quite okay. So let me start by doing group add sales and group add account. I know these groups already exist on my system, but hey, I just wanted you to see the commands that you need to be doing. And next, let me do user add Caroline and Lisa. I don't have to do that because I already have a Lisa. I also already have a Lori, and I have a Bob. So let me add these users to the groups. Because I want to clean up my group membership a little bit, I'm attacking the group file directly. We need Lisa and Caroline to be a member of the group sales. So I don't want to have Lisa in the group account. Let me remove her from there, and Lisa and Caroline need to be in the group sales. Caroline, there she goes. And then Lori and Bob need to be a member of the group account. So let me add Bob here. And that makes all of the first 4 questions alright. Then we need to create a directory with the name data sales. I removed the directories that I previously used in my demonstrations. So let me do mkdir sales again and mkdir account as well. ls-l, and since I'm root, you can see that user root and group root is the owner of these 2 directories. I don't want that. I want the user account to be group owner of the directory account. So chgrp account will do that for me, and chgrp sales will do likewise for the group sales. Now we want members of the other group to be able to read to these directories, and that is something that we need to take care of by using ACLs. But hey, before we go on, let's have a look at the current permission settings, which are not that good as well. So we have the user who has read, write and execute, the group who has read and execute, and others who has read and execute as well. I want the group to have read, write and execute, and the others to have nothing. So chmod 770 on star will do that for me. Now that I'm done with the default permissions, with the regular permissions, I can start applying access control lists. Please do remember that you need to complete your regular permissions before you dive into the access control lists. So what we're going to do here is set facl -r. We don't really need -r here, but I want you to be used to use -r at all times, because it doesn't harm in any way if you don't really need it. So g account and rx on sales, and after doing that we also need to apply the default ACL. So that is the same command with d : in front of the group assignment. And next we can do set facl -r -m g : sales : rx on account. And there also we need the default assignment. ls-l, did you notice the little plus sign that indicates that ACLs are set to this directory? It wasn't there before because we didn't have any ACLs before. So if you just have a look at one of the directories as an example, that would be get facl, of course. We can see that all is set in the way the exercise wanted it to be set. And that's all.
So in this important lesson you have learned how to manage permissions. We have seen all 3 the systems of setting permissions, the basic permissions, the special permissions and access control lists as well. You should know that managing permissions is core for a Linux system administrator. So you should absolutely be comfortable with everything that we have covered in this lesson.